Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, I'll show you the steps on graphing these three given linear inequalities in two variables. The most important steps in this lesson are graphing the boundary line that separates or cuts the XY plane into two regions and shading the appropriate region. The appropriate region is the region containing all the points with X and Y coordinates satisfying the original inequality. We have four inequality symbols: greater than or equal to, less than, and less than or equal to. If there is no equal component to the symbol, that means the inequality symbol used is greater than or less than. We use a dashed boundary line. We use a solid boundary line if there is an equal component to the symbol. That means the symbol used is greater than or equal to or less than or equal to. Let's refer to the three given linear inequalities. For the first inequality, the symbol used is less than or equal to. There is an equal component to the symbol. That means we are going to use a solid boundary line for the first inequality. For the second inequality, the symbol used is less than. There is no equal component to the symbol. Therefore, we are going to use a dashed boundary line for the second inequality. For the last inequality, we are going to use a solid boundary line because the symbol used is greater than or equal to, and there is an equal component to the symbol. Let's graph the first given linear inequality. We have y is less than or equal to x plus 4. Step 1, replace the inequality symbol with an equal sign. The related equation is y equals x plus 4. This is the equation of the solid boundary line. Note that there is an equal component to the given symbol, so we have to use a solid boundary line. Step 2, construct the solid boundary line. How do we construct the solid boundary line? We can choose any of these three methods. First method is by finding 2 points. Second method is by using the y-intercept and slope. Third method is by using x and y-intercepts. I will be using the x and y-intercepts to construct the solid boundary line. How do we solve for the x-intercept? Remember that x-intercept is a point along the x-axis. Any point on the x-axis has a y-coordinate 0. That's why when solving for x-intercept, we always set y to 0. Our related equation is y equals x plus 4. Set y to 0. Then solve for x. To solve for x, we have to isolate the variable on the right side of the equation. By subtraction property of equality, subtract 4 from both sides of the equation. Left side minus 4, right side minus 4. Cancel out opposite numbers. X is isolated on the right side of the equation. The left side becomes the difference between 0 and 4. 0 minus 4 is equal to negative 4. Therefore, our x-intercept is at negative 4, 0. The x-coordinate is negative 4, the y-coordinate is 0. How do we solve for y-intercept? We set x to 0. Y, any point along the y-axis has x-coordinate 0. That's why we set x to 0 when solving for y-intercept. So from y equals x plus 4, replace x with 0 and solve for y. Y equals 0 plus 4. Any number added to 0 is always equal to the number. Therefore, y is equal to 4. Our y-intercept is at 0, 4. 0 is the x-coordinate, 4 is the y-coordinate. Let's now plot the x and y-intercepts. We have our x-intercept at negative 4, 0. This is where the boundary line cuts the x-axis. Negative 1, negative 2, negative 3, negative 4. This is the x-intercept of the solid boundary line. Let's plot the y-intercept. This is where the boundary line cuts the y-axis. Our y-intercept is at 0, 4. Positive 1, positive 2, positive 3, positive 4. This is the y-intercept of the boundary line. Now let's construct our solid boundary line. This is the solid boundary line of the first given inequality. Step 3, let's determine which of the two regions to shade. To determine which of the two regions to shade, we are going to pick the origin as our test point. Remember that the x and y coordinates of the origin are both 0. If these coordinates satisfy the given inequality, then we are going to shade the region that contains the origin. This is the origin, the intersection of the x and y axes. If these coordinates do not satisfy the given inequality, then we are going to shade the region that does not contain the origin. Okay, so let's replace x and y with 0. Left side becomes 0, less than or equal to 0 plus 4. 0 is less than or equal to 4. Is 0 less than or equal to 4 a true or false inequality statement? This is a true inequality statement. Since this is a true inequality statement, we are going to shade the region that contains our test point. This is the region that contains the origin. This is the graph of the first given linear inequality. Let's graph the second given linear inequality. We have y plus 2x is less than 5. Step 1, change the inequality symbol into an equal sign. From y plus 2x is less than 5, we now have y plus 2x is equal to 5 as our related equation. This is also the equation of the dashed boundary line. There is no equal component to the given symbol, so we are using dashed boundary line. Step 2, construct the dashed boundary line. Again, we are using the x and y-intercepts to draw the boundary line. To solve for the x-intercept, we set y to 0. From y plus 2x is equal to 5, replace y with 0 and solve for x. 0 plus 2x equals 5. Any number added to 0 is always equal to the number. So 2x is equal to 5. To isolate x, let's use division property of equality. Divide both sides by 2. Left side divided by 2, right side divided by 2. Cancel out 2. X is isolated on the left side. X is equal to 5 over 2. Therefore, our x-intercept is at 5 over 2, 0. The x-coordinate is 5 halves or 2.5. The y-coordinate is 0. Let's solve for the y-intercept. To solve for the y-intercept, we set x to 0, then solve for y. Y plus 2 times 0 equals 5. Any number multiplied by 0 is always equal to 0. Y plus 0 is equal to y. Therefore, y is equal to 5. Our y-intercept is at 0, 5. The x-coordinate is 0. The y-coordinate is 5. Let's use the x and y-intercepts to construct the dashed boundary line of the second inequality. The x-intercept is at 2 and 1/2, 0. 2 and 1/2 is midway between 2 and 3. 1, 2, 3. This is the x-intercept of the boundary line. The y-intercept is at 0, 5. 1, 2, 3, 4, 5. This is the y-intercept of the boundary line. Draw a dashed line passing through the intercepts. This is the dashed boundary line that separates the xy plane into two regions. Step 3, determine which region to shade. We are going to use the origin as our test point. If these coordinates satisfy this inequality, then we are going to shade this region, the region that contains the origin. If these coordinates do not satisfy the inequality, then we are going to shade this region, the region that does not contain the origin. So let's replace x and y with 0. 0 plus 2 times 0 is less than 5. Any number multiplied by 0 is always equal to 0. 0 plus 0 is equal to 0. 0 is less than 5. Is this a true or false inequality statement? 0 is less than 5 is a true inequality statement. Therefore, we are going to shade the region that contains our test point. This is the region that contains our test point. This is the graph of the second inequality. Let's now graph the last inequality. We have x minus 4y is greater than or equal to 6. Step 1, replace the inequality symbol with an equal sign. From x minus 4y is greater than or equal to 6, we now have x minus 4y equals 6. This is the related equation which corresponds to the equation of our solid boundary line. We will be using solid boundary line because there is an equal component to the given symbol. Step 2, construct the solid boundary line using the x and y-intercepts. Let's solve for the x-intercept. Set y to 0. From x minus 4y equals 6, replace y with 0. We now have x minus 4 times 0 equals 6. Any number multiplied by 0 is always equal to 0. So x minus 0, which is equal to x, equals 6. Our x-intercept is at 6, 0. The x-coordinate is 6, the y-coordinate is 0. Let's now solve for the y-intercept. To solve for the y-intercept, we set x to 0. So from x minus 4y equals 6, replace x with 0. 0 minus 4y equals 6. 0 minus 4y is equal to negative 4y. Negative 4y equals 6. To solve for y, let's isolate it on the left side of the equation. Use the division property of equality. Divide both sides by negative 4. Left side divided by negative 4, right side divided by negative 4. Cancel out negative 4, y is isolated on the left side, and it's equal to negative 6/4. Reducing the fraction to lowest term, we have negative reduced by 2, 3/2, or negative 1 and 1/2. Our y-intercept is at 0, negative 1 and 1/2. The x-coordinate is 0, the y-coordinate is negative 1 and 1/2. Let's now plot the x and y-intercepts to construct the solid boundary line. Our x-intercept is at 6, 0. 1, 2, 3, 4, 5, 6. This is the x-intercept of the boundary line. The y-intercept is at 0, -1, and 1/2. -1 and 1/2 is midway between -1 and -2. -1, -2. This is the y-intercept of the boundary line. Let's draw a solid boundary line passing through the intercepts. This is the boundary line of the third inequality. It divides the xy plane into two regions. Step 3, let's determine which region to shade. Again, we are going to use the origin as our test point. The x and y coordinates of the origin are both 0. If these coordinates satisfy this inequality, then we are going to shade this region containing the origin. If these coordinates do not satisfy this inequality, then we are going to shade this region that does not contain the origin. Let's find out. Replace x and y with 0. 0 minus 4 times 0 greater than or equal to 6. Any number multiplied by 0 is always equal to 0. 0 minus 0 is greater than or equal to 6. 0 minus 0 is 0. 0 is greater than or equal to 6. Is this a true or false inequality statement? 0 greater than or equal to 6 is a false inequality statement. That means we are going to shade the region that does not contain the test point. This is the region that does not contain the origin. This is the graph of the third inequality. That's it. We're done with graphing the three given linear inequalities in two variables. If you have any questions, you want further clarification, or you want to give feedback on this video, feel free to post your comment. Again, this is Tutor Marife MCP. Thank you for watching.